Carbon is, of course, an important element for life. Understanding its movement within an ecosystem and between an ecosystem and the surrounding environment allows us better to understand ecosystem function. Apart from this, with growing concern regarding anthropogenic climate change and discussions over carbon budgeting, it is essential that we understand the movement of carbon to assist in devising effective measures and methods aimed at slowing the rate of CO2 concentration increase in the atmosphere. Comparing, for instance, the atmospheric concentrations of CO2 at the Calperum-Flux tower to the global averages and long-term trends shows just how much localized variation can occur at a specific site over time. Better global coverage, including the information collected from the Ozflux network across Australia, help to improve our confidence in the global averages. Even at a single site, the atmospheric concentrations fluctuate over time and can be affected by localized events, such as agricultural burns, controlled burns, or bushfires, although luckily we haven't had one of those near our site so far. The Calperum-Chowilla Flux Tower is unique in that it is the only such research site collecting data from the vast mallee woodland across southeast Australia. By analysing the movement of carbon into and out from this ecosystem, largely due to respiration and photosynthesis, we have begun to make some estimates of primary productivity of the research area. The amount of carbon taken in through photosynthesis varies over time, and even though the 2 Novembers of the research period so far have indicated that the site becomes a slight source of carbon, overall the mallee woodland environment that we've been observing is a carbon sink, taking in as much as 600 grams of carbon per square metre each year. The site became operational just prior to the break in Australia's recent drought, which lasted for more than a decade. So we have yet to explore how the mallee woodland copes under such stress. It is likely that the site would have a reduced net primary productivity value. It's through long-term research projects consisting of networks of observation sites, such as Ozflux, that we will better understand our ecosystems, the movement of carbon, and can better protect our natural resources and act to reduce the potential impact of anthropogenic climate change.